All right, so today we're on 11.3 on L'Hopital's rule. So this will be an introduction, and then L'Hopital's rule and the indeterminate form is 0 over 0, the one-sided limits and limits at infinity, and L'Hopital's rule and the indeterminate form at infinity over infinity. All right, so L'Hopital's rule is a technique to evaluate limits of quotients. Now, one must be familiar with the limit properties of basic functions, and there are a few here below, and so we're going to use these really to help us do a lot of the limits. So we have to kind of remember what these graphs look like. So when we have y equals x, you get a straight line. It's either like this or like this. And so the limit of x as x goes to 0 is 0. And then the limit as x goes to infinity is positive infinity and negative infinity as it goes to negative infinity. And then if you had a negative one, then it would be opposite direction. All right, so then for x squared, as it goes to 0, it becomes 0. And then as it goes to positive infinity, it goes to plus infinity. And as it goes to negative infinity, it goes to positive infinity. Now here we have 1 over x. So as x goes to 0 from the right, so from this direction, it goes to positive infinity. As it comes from the other direction, it goes to negative infinity. As it goes to positive infinity, it goes to 0. And as it goes to negative infinity, it goes to 0. So those are good things to remember here. And then we have 1 over x squared. So as we approach 0 from the right, it goes to positive infinity. As we approach it from the left, it goes to positive infinity. As we approach positive infinity for x, it goes to 0. And as we approach negative infinity for x, it goes to negative infinity. I mean to 0. And so those are kind of the ways that that works. And then we can say then as x goes to 0, both on this one, it goes to infinity, but because these are opposites, it does not exist. So we forgot to mention that one and that one there. So those are kind of things to do. Now, what we'll see in our problems in this section is we're going to have, instead of just x squared, we might have x minus 5 squared. And so this can be shifted to the right, or x plus 5 is going to be shifted to the left. But it's still going to have the similar shape and similar kinds of behaviors. Same with this one. It might be 1 over x minus 1 or something like that. And so you're shifting left or right. Same with this one. So that's something to kind of remember when we're doing these. Now, the limits of the previous figure are easily extended to functions in the form f of x equals, again, like I was saying, the x minus c to the n, and g of x is 1 over x minus c to the n. In general, if n is an odd integer, then the limits involving x minus c to the n or 1 over x minus c to the n as x approaches c or plus or minus infinity behave respectively like the limits of x and 1 over x. So it's going to behave like these. Now, if n is even, then the limits involving these expressions behave respectively like the x squared or 1 over x squared. Oh, so it's going to be like the x squared and the 1 over x squared. So it's going to behave like those. And so no matter if we have just the 1 over x or the ones with plus or minus c, then it's going to behave in a similar fashion. So with that said, let's work on our problems here. So the first one is we have limit as x approaches 3 from the right of 7 over x minus 3 to the fifth. All right, so with this one, that's an odd number. So let's go back to our picture. If it's an odd number and it's 1 over that, we're going to compare it to this function here. Now, basically, with this one, it's shifted to the right. So the x minus 3 means it's going to be shifted over to the 3. And so it's going, when we come from, I think it was from the right side, it's going to be coming up here and it's going to go up to a positive infinity. So what we can say then maybe for A is we can say for A, we're going to compare to 1 over x and shifted to the right because that's what the minus 3 does. And so that's going to give us, it's going to equal that limit is going to be infinity. Now for B, what are we going to do there? Well, it's going to be an even, and so we're going to compare to 1 over x squared. Now this one's shifted to the left, and it's to shifted left by 4, and so we're going to approach the negative 4, and what's it going to do there? Well, if we look at our x squared as it goes this way, and we're comparing that, well, it's going to go to positive infinity. Okay, because that one represents more of this one, because we both go both from the left and from the right, we go to positive infinity, and therefore, when we approach that negative 4, it's going to be positive infinity. So it's going to be infinity. All right, now C, we're going to have 1 over x. Again, we're going to compare it to, so compare to 1 over x, and this time it shifted left. And so now what is that going to be? And we're going to negative infinity. And so if we compare it to 1 over x, shifted to the left and going to negative infinity, well, it's going to go to 0. Okay, so that's going to be that one. And so then maybe for D, we're going to compare to x squared. And when we do that, as x goes to infinity, well, guess what? As x goes to infinity, it's going to go up here and go to infinity as well. Okay, so then it's going to equal infinity for that limit. All right, so again, we're going to do a lot of stuff comparing to these graphs. So knowing how they work, moving left and right, is going to really help us to be able to solve some of these limit problems. All right, so let's stop there and we'll come back for more.